Greetings. I am Rajkumar Parashari and I love doing physics. Today I am here with an instrument, a screw gauge, also called as a micrometer. Today's objectives are: first, to identify part of a screw gauge; second, to understand its working principle; third, to do experiments as suggested in CBSE curriculum. Before I help you to identify various parts of a screw gauge, I think I should give you a brief recap of nut and bolt. Over here, the bolt has iron threads on the outer surface, while the nut has iron threads on its inner wall. Is that right? Now what you do, you hold a nut in one hand and bolt in the other hand. Plug the bolt into the nut and turn. So the bolt covers the angular displacement. Now as the bolt covers the angular displacement, and notice simultaneously it is going into the bolt and comes out of it. Is that right? So bolt not only covers the angular displacement but also traverses the linear displacement, and you will notice the angular displacement of the bolt is directly proportional to the linear displacement covered by itself. Is it right? And I will come to this part once again while explaining the principle. Now the parts of a screw gauge. A screw gauge necessarily has a U-shaped frame. One end of the frame is attached to a long nut. In fact, you could see as I unscrew it, the bolt is coming out. It's a specially designed bolt. So here is a specially designed long nut. The outer wall of this nut has a meter scale etched over it, while the inner wall has the iron threads. If I look at the opposite end, there is a projection coming out, and the length of this projection can be adjusted using this screw. So it is, the second part is a bolt. It's a specially designed bolt, and you could see the outer surface has these iron threads. The separation between any two consecutive iron threads is called as the pitch. Part of the bolt is covered by coaxially placed cylinder, metallic cylinder. This is also called as the thimble. The tapering part of this cylinder has a circular scale. And there are how many circular divisions over there? There are 100 circular divisions over there: 10, 20, 30, 40, 60, 70, 80, 90, and 0. Means there are 100 divisions on this circular scale. The other side of the thimble is attached with a part known as ratchet. Now what you do is you plug this bolt into the nut and turn it. Keep turning it. The bolt comes out of the other end. The bolt has come out. Keep rotating. Now as you rotate it, so what is happening? The separation between the front with the moving stud and the fixed stud decreases. So keep rotating, and at a particular point what happens is that the separation, the gap reduces to 0. Now rotate it further and try to listen the sound made by this ratchet. Could you listen this tick tick sound? And you should make 3 sounds from the ratchet, and this will ensure that these two studs, the moving stud and the fixed stud, they have been optimally pressed. Is that right? At this point, I do notice that the 0 of the circular scale is above the reference line, and I should also let you know where the reference line is. You see, this main scale, the main scale is etched over this straight horizontal line. This straight horizontal line is called as the reference line. So as you turn, what's really happening? That the 0 of the circular division has moved above this reference line. Is that right? And in this case, we say that this screw gauge has a negative zero error. And what really it means, I may come up with the other video, but I will let you know, I mean, how much is the value of this negative error. You need to wait. And I have another set of screw gauge with me. So in this screw gauge, as you could notice, this is the U-shaped frame with a long nut, and this is the specially designed bolt. You know, this is the bolt, and this is the coaxially placed metallic cylinder, and the tapered side, the ratchet, the separation between any two consecutive threads is called as the pitch. You already aware. And this special case, you will notice, I have noticed that the separation between any two iron threads happens to be 1 millimeter, and let you know how really I have calculated. You need to wait for some time. Now plug it. Now as you keep rotating, let's see that the spindle has come out of the other end of the bolt. The separation between the two studs is decreasing. Now the moving stud has touched the fixed stud. Now turn this ratchet 1, 2, 3, 3 ticks. Now optimally pressed. Now in this case, if you could see that the zero of the circular scale is under the reference line, and hence in this case we say that this screw gauge has the positive zero error. Now the principle of this screw gauge, we are already aware that the angular displacement of the bolt is directly proportional to the linear displacement covered by the bolt. So what really I mean is that the linear displacement of the bolt is directly proportional to the angular displacement. That is, x is equals to constant of proportionality into theta. This constant of proportionality happens to be the least count of the screw gauge as well. Let me explain this to you, that this C equals to x by theta. Is it right? This C can be defined as linear displacement covered per unit angular displacement produced in the bolt. Further, for n rotation of the bolt, the angular displacement should be equals to n multiplied by 360 degree. If you want, you can write it in radians as well. And the linear displacement will be equals to n times pitch. I hope you know it. You try this by yourself. As you rotate the bolt by one full rotation, the bolt moves ahead by an amount p in the forward direction, or by the same amount in the backward direction. In the normal situation, I mean, in this case, pitch happens to be the 1 millimeter. So for one full rotation, bolt will either move ahead by 1 millimeter in the forward direction, or will come back by 1 millimeter in the backward direction. Now next, this n and this n will cancel, and this is further equals to P divided by, the unit happens to be millimeter per degree. Further, we could have tried to make 360 divisions on the circular scale, and that appears practically nearly impossible. So either in normally or the commercially available screw gauge, you will either have the 50 divisions or 100 divisions. In some cases, number of divisions on the circular scale you can find to be 200 as well. And that is why I need to convert this unit from millimeter per degree to millimeter per division. And let's see that how really this could be done. This could be done by multiplying denominator by 100 as well as dividing it by 100. This is millimeter per degree, and this is further equals to P divided by 100, and this part within the denominator is equals to 1 division. 1 division for this screw gauge 1 millimeter per division. So this will be the least count. This will be the least count of this screw gauge. And if you want, you can write P to be 1 millimeter. So this is equals to 1 millimeter divided by 100 division, and this is equals to 0.01 millimeter per division. This happens to be the least count of this screw gauge. Let's try to look at the same calculations had number of divisions on the circular scale be n. In that case, this formula, the least count, would have changed like this. C is equals to P millimeter by 360 degree equals to P millimeter divided by, because the number of divisions on the circular scale are n, let's write a small n, multiplied by 360 degree upon n, and this should give us this quantity. 360 degree upon n should give us number of divisions on the circular scale. So this is equals to P by n millimeter per division. So the least count of the screw gauge in general is given by the expression C is equals to P by n. Now observations using a screw gauge. Before taking observations, we must be knowing its zero error. It could be positive as well as negative. To find its zero error, hold the screw gauge in hand and turn the ratchet. Keep turning the ratchet. The separation between the studs closes in. At a particular moment, it reduces to zero. Keep turning further and try to listen 3 tick sounds. Now, these two studs are optimally pressed. Now try to see the position of zero of the circular scale with respect to the reference line. To show it with clarity, I will take a snapshot and will show you its magnified image. Zero of the circular scale is above the reference line, and hence the error is negative. And further, you can see that it is the 9th division of the circular scale that coincides with the reference line, and hence the negative zero error should be ninth division multiplied by 0.01 mm per division equals to 0.09 mm. As per the objective, I am supposed to find diameter of a given wire. So over here is a wire. I am also supposed to find thickness of a metallic sheet. So over here is a metallic sheet. I will be using the commonly available steel scale. So let's try to find out diameter of a given wire. So over here, this is the wire. This is a screw gauge. Try to hold this wire within these two studs. Now turn the ratchet to hold it between these two studs. Once this is held, now what you do is that you keep turning the ratchet till you hear 3 tick sounds. Okay, now this wire is optimally pressed. Try to read the main scale reading and the circular scale reading to find out its diameter. I'll take a snapshot and will show you the magnified view. From this magnified diagram, we can make out that is a 0th division of the main scale that is visible to us, and 60th division of the circular scale coincides with the reference line, and hence the main scale reading got to be 0 mm, and it is the 60th division which is coinciding, and that is why the screw gauge reading got to be 60 division multiplied by 0.01 mm per division, and this is equals to 0.60 mm. Now add the main scale reading and the screw gauge reading to obtain the total reading, and the total reading got to be 0.60 mm. For the next reading, unscrew and hold the wire at a different place. Again, I am showing the magnified view of what is visible to us over here. This time again, it is the 0th division of the main scale that is visible to us, and the 60th division of the circular scale that is coinciding with the reference scale, and hence we should be writing main scale reading to be 0 mm and the circular gauge reading to be 60 division multiplied by 0.01 mm per division, and this is equals to 0.60 mm, and the total reading, the main scale reading plus the screw gauge reading, this is equals to 0.60 mm. Similarly, we can take more readings while holding this wire at different places, and every time we notice that the main scale reading is 0 millimeter, and it is the 60th division of the circular scale that coincides with the reference line, and hence let I fill up this table. Now the average thickness of the wire or the diameter of the wire, this is equals to 0.60 plus 0.60 plus 0.60 plus 0.60 plus 0.60 divided by 5, and this is equals to 0.60 millimeter. Now the corrected value, corrected diameter, as the zero error is negative, and hence we need to add this negative zero error to the average diameter of the wire. This is equals to average diameter plus negative zero error to be added plus zero error, and this is equals to 0.60 mm plus 0.09 mm, and this is equals to 0.69 mm. So this is the thickness or the diameter of the given wire. And if we want to find out the thickness of the metallic sheet given, we can find out in the same way. We'll have the same table. Now let me do it quickly for you. Now let us try to find out thickness of the metallic sheet given to us using the screw gauge. The procedure happens to be the same. You need to hold this metallic sheet or this steel scale within these two studs. Keep rotating the ratchet till you hear three tick sound. Once this is done, you try to read the main scale reading as well as the circular scale reading. So I'll show you the snapshot. So it is obvious from the magnified diagram of this image that the main scale reading is equals to 0 millimeter, and it is the 73rd division of the circular scale coincide with the reference line, and hence the circular scale reading is equals to 0.73 mm. And hence main scale reading is 0 mm and the circular scale reading is 0.73 mm, and the total reading got to be 0.73 mm. For the next reading, you need to hold this scale at a different point and again take the reading. This time I found that the main scale reading is again 0 mm, and it is the 73rd division that is coinciding with the reference line. So let I rewrite this again. This is 0 mm and this is 73rd division that is coinciding, and hence circular scale reading is equals to 0.73 mm. The total reading is 0.73 mm. Now take more reading while holding this scale at different places and fill up this table. And what I found, every time reading of circular scale was 0.73 mm. And hence now take the average thickness of the sheet. This got to be 0.73 mm. You add these values and divided by 5 will arrive to t equals to 0.73 mm. The next part, corrected value. Corrected value of the thickness. Corrected value of the thickness. And we know that we need to add the negative zero error to this thickness, and this got to be 0.73 mm plus 0.09 mm, and this becomes corrected value of the thickness of the steel scale. Class, I also wanted to share this with you. If you're asked to find thickness of one page, what you should be doing is that measure the thickness of 20 pages in the same fashion and divide pages of 20 thickness by 20 to find thickness of one page. So thank you so very much for listening this long patiently. God bless you.